Hi, welcome back. Today we're going to be taking a look at what we need to do to prepare for the AP Computer Science A exam. We want to get this whole year down in just a few short minutes. We're going to go through and talk about all the topics we have to do. Here's a quick list of the topics we're going to be going over as we go through this review on this. We've got syntax, primitives, objects, math, strings, loops, logic and De Morgan's law, design, array, ArrayList, 2D arrays, sorting, searching, errors and exceptions, inheritance, recursion, and a couple tricks you can do to help it do a better job on the exam. Now, if you need to go through and scrub through the video to find specific spots, you can do that. This is the basic outline I'll be using as I go over all the concepts on this topic, but you can also find way more information on details on all these different topics on my channel. There's videos for every single one of these. You've got more detail if you need to review this, but this is just a great way to review 45 minutes before the exam, freshen your mind up with all the topics you need to know so you can do a great job and take that AP exam in May. So let's go ahead and take a look to see what we have to do as we go through this. First thing we have is the declaration syntax. This is when we're trying to make a variable inside our Java program. So the basic structure is type name and then variable and a semicolon. As you can see right here, we have some examples with int frog count, boolean has paintings, string favorite phrase, and demo object example. We're using the camel case notation where we have the lowercase first part of the word and then our second and following words are all capitalized so we can easily understand that and read this. And it's just the type and then the name. And so we'll use the name for that as we're declaring a variable. When we declare a variable, it simply just says, oh, here's a variable reference. It doesn't have anything inside it yet. If this is a local variable, then no value at all is assigned. It's not even a default value of null or zero. It's just an empty variable not doing anything. If you try and access this, it'll cause an error. If this is an instance variable, if you simply just declare it, it will hold the default value. Instance variables, for all primitives, the value is either 0 for everything that's not Boolean and false if it's Boolean. So those are the default values for that. For every object that's a data member, instance variable, or one other word you want to call for that, it's going to be null. So strings, arrays, ArrayList, cars, toasters, whatever you're making in Java, those default values are all null. And so when you declare a variable, it simply just has that value in it as a data member. If it's a local variable, there's no value assigned to it whatsoever. So you have to make sure you assign something to it before you try and use it. Otherwise, it's going to cause an error. Our next thing we have is the initialization syntax, so we can actually go through and initialize the values of the variables we're working with right here. We're going to start with primitives, then objects, then talk about it a little bit more. So with primitives, we can have variable equals value followed by a semicolon. So we have frog count equals 9. I'm taking a literal value of 9 and assigning that to the frog count variable that we declared earlier. I can also say variable equals expression, of course, followed by our great friend the semicolon. And in this case, I'm going to say frog count is assigned 9 times 3 minus special item count, some variable I've defined earlier. And so I can do any complicated or simple expression. I can grab any information and assign it to a variable that is a primitive type, no problem. For an object, we've got the idea of initializing with an actual value. We call it constructor. And so we have variable equals new constructor call followed by the semicolon. So I have my duck is equal to new debug duck. That's using the default 0 parameter constructor. So it simply just assigns that value to it. Again, we have to have that new keyword because we're initializing a new object. Always a key thing when we're working with objects. I can also have a parameter-based call, so I have variable equals new constructor call with parameters. In this case, my duck is equal to a new debug duck, passing it the name smartypants as a string, and then 23 for its question count. Take a look at my videos on how to work with debug ducks and doing sorting and searching through that. You can use that to see where we're referencing that information. We can also assign into a variable via a method. This will work for either primitives or with objects, and so it's just variable equals the result of that method call. And so I have frog count is equal to simulation.getJumpingFrogAmount. So we assume that there is a int-based method called getJumpingFrogAmount and assigns that value into the frog count variable. We also have my duck is equal to classroom.getNewestDuck. So my classroom object, whatever type of thing that is, has a method that returns a duck object to it, and I can put it inside there. And so that's the way we can initialize values. We have the direct initialization with primitives and with objects when we call either assign a value to it or use the new to call the constructor call, or we can use methods where we take the result of some method calculation, does a method work that happens, and assign that result into the reference variable we're working with. When we're talking primitives, there's 3 different types of primitives we have to know for the AP Computer Science A exam. We have ints, doubles, and booleans. So ints are our counting numbers. These are numbers from plus or minus 2 billion. Now remember, we have one more number on the negative side because of 2's complement, so there's that little bit that we need to know, but that's all we have to worry about with that. When we're talking about doubles, this is the realm of the real. And so this is plus or minus 2 times 10 to the 306. Wowzers, lots of stuff, lots of numbers in there, but we also have special values of positive and negative infinity, and because we're dealing with real numbers, we can also support dividing by 0 with real that we can't do with an int. That's where NaN comes into play. With Boolean, we only have true and false values. That's the foundation of Boolean logic. We'll work with that a lot as we go through, and you're going to see a lot of examples of this on the exam. But just in case you have any reviews of that, take a look at the Boolean logic so you can go over those details. The key thing we have to remember when we're talking about primitives, though, is whenever I'm working with primitives, I get a copy of the value when I'm working with parameters or returning from a method. So if I give you a 7, my original 7 that I have in my pile of code is still fine and happy, but you have a new 7 that you can do anything you want with. That goes for any primitive value. Primitives, you get copies of those values. When we're talking about objects, it's everything we make in Java besides primitives. So it's every kind of capital T type you create in Java. Again, when we're making objects, they always start with capital letters because we have good naming conventions. When we're talking about objects, we also pass these by reference. And so this is the idea that when I send a variable on that, I'm giving a reference to the existing object. So if I have a puppy on a leash right here, and I can hold my puppy by its leash, and I can walk the puppy. And if I let you walk my puppy as well, that's still my puppy. You're just holding a leash to it with your variable reference you're talking about. Or my best example, we have a bottle of sriracha. And so my bottle of sriracha, if you need some sriracha for your assignment, or if you need some sriracha for your lunch because it's not spicy enough, you can borrow my sriracha, pour it on there, but the sriracha level in my sriracha bottle, of course, is going to go down because you're referencing my object right here. This sriracha bottle is still being talked about, so if you have sriracha, it's like, oh, I'm going to use this sriracha. I don't just get a copy of sriracha. That'd be great and wonderful, but that doesn't happen. So again, when we're talking with objects, we have a reference to it, and in that case, I have my sriracha, and so if you affect my sriracha is affected. You can use it on yours, but it'll decrease the level of my sriracha as you put sriracha on your sandwich. When we're talking about objects, we also have the coolness of the constructor. The constructor has a couple rules for it. It needs to be the same name as the class. There is no return type for it. And of course, with good naming conventions, it should always be capitalized. The job of the constructor is to build the class. This initializes all the data members. That way we don't have any null pointer exceptions. That's the main thing we want to make sure we do when we're writing our constructors, take all the data members and make sure they're initialized. If you have any parameters that are sent to the constructor, that's usually designed to actually assign those values to the variables that belong, or the data members that belong to that class or object. When we're calling the constructor, again, we always call the constructor with that new keyword. So new keyword is always going to be prefaced before the constructor call. So we'll see that inside all of our Java code. Methods are the next thing we build when we're talking about objects. Methods are what we're doing to make actions inside that. They should do one thing well as a design purpose, so it's what it's supposed to do. The name should reflect the purpose of that method, what the action is supposed to be performing. Now that is not guaranteed to be the case, actually guaranteed to not be the case on our multiple choice questions. You'll get method names like mystery or does something because they want you, the test taker, to figure out what's going on in that method by reading the code that's attached to it. But when you're writing your methods, of course, you should have that method itself have the name that reflects what it's doing. The parameters in the method are designed to provide information that should be used or manipulated. So if you're given information as a parameter, that information should probably be used to design to make that method more useful. Local variables inside those methods must be initialized, especially that local variable is a return value. So you always want to make sure when you're dealing with local methods inside a method, you want to make sure that anytime you're working with local variables inside a method, you initialize those values appropriately so you can return them and use it and not cause errors in your code. Our method structure is syntax. When we're actually writing a method, we have the idea that our header itself has the visibility, then its return type, the name of the method, and finally the formal parameters that are enclosed inside parens, aka parentheses, followed by the body of the method itself. We have a couple short examples right here. We have public void start, open and close parens, followed by our squigs in our code. We have private string most common letter. It takes a string sample, and then of course the code that implements that method. And finally, public int matching word count, string source, comma, string array data, and then the math stuff that goes along with it. So we have the idea that we have our formal parameters on the outside. It has the name of the type, and then the variable that we're referring to it, and those are separated by commas if we have more than one. And that's the actual structure for writing the actual method header itself. If we're calling a method, the call itself only uses the actual parameters. These are things we're sending to it to actually get that information back. These can be a literal, these can be a variable, it could be a method call, or even a constructor call for that. So I have matching word count passing an empty string and the result of my getWords method call. I have matching numbers passing at 3.14 and the variable results. I have my add duck to class call, and I pass it a new debug duck passing the name of Quaxers to it. So I'm creating a constructor call in there and assigning that as a new duck to add to the class. And so that's a couple examples of how we can use methods inside an object. Here we have some sample code to go over the idea of the methods. We can actually see the actual structure of the method itself as well as method calls inside it. On that top example, we have public string random data. It takes two string parameters, first and second. We have a string result local variable that's assigned the combined length is. Then we say int length, another local variable, in which is assigned the value of first.length plus second.length. And so first.length and second.length are calls to the methods of the string class, where I'm getting the length of each of those two strings. And then I say result plus equals length. So I'm going to say the result value, the common length is, and then whatever value is supplied as the length of those two different parameters added together, and that's what's returned as the result. So we have an initialized value that's returned and sent back on that. We also have our private void use phone method. I have a smartphone class I have a smartphone variable named demo that's a new smartphone. So I initialize that new smartphone object, so I'm calling its constructor. I have system.out.println. I'm calling a method on there where I'm doing the phone has a camera of, and I'm asking it to get the camera type from that and appending that to the string that I print to the screen. I have then string important info is assigned the value of demo.randomData, passing it demo.getCameraType, comma, and then demo.getServiceProvider, that method we just defined up above, where it's going to say that, hey, I'm going to get the combined length is, and then however what the length of the string of camera type and service provider are. And then I'm going to do this amazing thing. I'm going to say system.println, the critical information is, and then important info. So that information I just grabbed from that, that's the important information that I did when I assigned that random data, and I pulled that in there, and that's the important information. So the combined length of those two strings are blah, 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 blah. Great, wonderful things. And so that's the critical information for that, using different examples of constructors, method calls, and local variables, so we can see how things are assigned. Those those first few topics that we just looked at. Arithmetic in Java, aka math. So PEMDAS is still a thing. So notice that there's two M's inside that PEMDAS. We have parens, we have exponentiation, which are handled by math operations. We have multiplication, then modulo, aka division with the remainder. We have division itself, then addition and subtraction, just like normal. Same order of operations applies. Integer-based arithmetic, however, never deals with decimals. When we're talking about the int data type, there's no decimals whatsoever. None. They don't exist. So we use casting, we want to convert numeric type, so int, not pi. I'm going to use parens around the data type int, so I'm going to take 3.14, cut the decimals off, and now I have 3. I'm going to say double HAL is, I'm going to take the value 9,000, turn it to a double, and now HAL has 9,000.0. So if you use the, when you're doing casting from numeric types, casting to an int will remove all the decimal information. It doesn't round, it just drops it off. So if it's 3.999999, it becomes 3. When I cast to a double, it adds 0.0 to the value. So it just appends 0.0 to that numeric value. The modulo operator, aka the M on that second N on PEMDAS, gives us the remainder of integer division. So int result is 23 modulo 4, so that contains 3, because if I divide 23 by 4, I have 3 left over. Think about the long division you did back in elementary school with that R on the end, and what left over, that's what goes there. So int result 1000 modulo 2 contains 0 because 2 is evenly, or excuse me, because 1000 is evenly divisible by 2, so we have a 0 left over, so that's what we have. So the remainder is what's stored inside that when you're using modulo-based division, so the modulo operator is what that is. For more advanced operations with math, we use the math class. This is where we do the really cool stuff with math. So we have math.abs. One of the examples I give in class is if you point your fist to your stomach, you get that nice V shape of an absolute value graph, because that's what it's doing. Math.abs is the absolute value. Math.pow is how we do exponentiation. So it takes a base as its first parameter, an exponent as its second parameter, and returns the base to that power. And either of those values, base or exponent, can include roots and negative values in that. So you can have 1 over x, 1 over x cubed, etc. And all those values can be calculated properly with that. So you can do all sorts of fun stuff. We also have math.squirt. We're going to take square root, cut all the vowels, and that's where we get squirt for that. And that's the square root for there. And that returns the square root of whatever number you supply to that as a parameter. Math.random is one of the most powerful methods inside the math class. And so because all these are called statically, we just do math dot for all of that in case I didn't say that already. And so this is a number that's between 0 inclusive and 1 exclusive. So starts at 0 and cool, a filled in circle, but up to but not including 1, that open circle on the number line. And a great example for that is we're going to take int of math.random times the difference plus 1 plus min, so we can get some random number on that, so we can actually get that value, so we can have the scalar on that and go from there. String. String is a kind of a huge big deal. We use them all the time. Strings, you have to remember, though, are objects. They support all kinds of text, ASCII values, Unicode values. That's where we're going to see this. So emoji, totally cool. We can use them inside strings. They may not display properly, but they definitely work. Strings, one of the key things we have to know is string is immutable. You can't change a string. The only way to change a string is to reassign a new value into it. You can also assign a string with a string literal. So string my string equals quote unquote what, okay? Or I can say string equals new string and pass it parens and pass it inside the parens the string value I want to do with that. Those are both ways to create string objects. However, we do not want to use the equals equals operator or the not equals operator to compare for equivalence when we're looking at strings. The equals equals operator is only designed to be used for a null check. The equals equals can also be used if you have to check to see if the variable right here is the same actual variable as the variable over there. But don't check to see if they're the same contents, only check to see if they are null or it's the same variable reference. That's all we use equals equals or not equals for on a string. Instead, we use the string methods to do all those comparisons. So string methods, the first method we have is length. It returns an int. It tells us how big the string is. If there's 0 characters, 1 character, 5 characters, 8,000 characters, whatever. That's going to be on that. This is the ordinal value. This is not the index, it's the ordinal. How many things are inside that? This is from 0 up to n based on how many things are actually inside that string. The dot equals method takes some string as a parameter and returns true or false if it matches exactly. Are the symbols in that parameter the same as the calling string? We have lowercase a dot equals capital A. That returns false because they are not the same string. Capital Q dot equals capital Q returns true. If I use the equals equals operator, there's no guarantee we're going to get any of those results with that. The index of method takes a string as a parameter and returns where we find it inside that as an int. So where do you find the parameter inside the calling string? If it doesn't find it, it returns -1 because the first possible index is 0. So if it's not found, it's going to give -1 because it's not there. There's a bunch more string methods that we have to know. Substring with a single parameter gets us the number from that spot up to the end of the string. So again, indices start off at 0, so we have 0, 1, 2, 3, 4. So if I pass it 3, I have 0, 1, 2, 3. I'm going to get this string and this string up to the end. So we're going to grab those pieces from that. Substring with 2 parameters is the 0-based first parameter up to, but not including that second parameter. So if I have substring 0, 2, I'm going to do 0, 1, but not 2, 3, or 4. So I'm going to just get those first 2 letters. And again, if I use substring with index, index plus 1, that gets me 1 letter at a time. Great thing to remember as we take the exam. The compare to method returns an int as well. This is like a way we can actually sort strings based on the values inside it. Is the parameter the same before or after the calling string in the dictionary? So lowercase a dot compared to lowercase z returns a negative value, in this case -25. Lowercase z dot compared to lowercase a returns a positive value of 25. And lowercase z dot compared to z returns 0. So that's the idea on that. You also do need to know that when you're comparing uppercase letters to lowercase letters, the uppercase letters are before all the lowercase letters, all of them in 0. So capital A as before lowercase z. So keep that in mind if you're looking at capital letters for comparisons. Probably not in the exam, but just in case you see that. Loops. This is when you want to do a whole bunch of things over and over again. I use a Simon Says analogy to talk about this in my classes. It's something we do all the time. So if Simon says, clap your hands, you're going to do this until you're told to stop. So undefined amount is a while loop. You don't stop until Simon says to stop that. That is our while loop analogy. Simon says, clap your hands 3 times. We clap 3 times. That's the for loop. It does it this many times. It's designed to execute a certain number of times in order. A structural loop, on the other hand, it says, Simon says, everyone in that row over there, clap your hands 5 times. Oh, okay. And it does it like that. So Simon says with the for each, does everything in that structure does the same thing. So that's what a for each is designed for. Here we have a while example. So I have a demo while loop method. My string user input is assigned empty string. As long as my user input is not equal to quit, my system.out.println is going to be type quit to stop. It's going to print that to the screen. And the user input is going to be user input.next line. I'm going to use the scanner to grab the next line from that, and it'll store it inside my user input variable. It'll then come back up to that while loop, check to make sure it's not equal to quit, and then print type quit to stop again over and over and over and over again. And it's going to repeat this until I finally type quit. When quit is on that thing, I've now met that condition. I stop that loop, and my loop will execute. I drop down and I leave the method. A for loop example right here, I have a private void demo for loop. For index is equal to 0, index is less than 100, index plus plus is the standard way to see a for loop. I'm going to go up from 0 up to, but not including 100. I'm going to print out the number of that each time. So it's going to go 1, 2, 3, 4, 5, 6. Great. Then I have a string sample equals supercalifragilisticexpialidocious. Wonderful, well, great to say. And so for index is equal to sample.length minus 1, I'm going to start at the very end of the string, and I go to -1 because I can't use the last spot. Index is greater than or equal to 0, index minus minus. So I'm going to go backwards through the list, starting at S, then U, then O, then I, then C, then O, then D, dot, 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 all the way down to U, then S at the very beginning. And system.current letters equals sample.substring index, comma, index plus 1. And so that's a great way to get 1 letter out of a substring right there. And you can do it going backwards or forwards as long as I have a positive number as my second number for both of those. And system.println current letter, print those out to the screen. With a for each loop, again, a demo for my for each, I'm taking an ArrayList of smartphone with a variable named phones as a parameter for this method. And for smartphone current smartphones, so for each smartphone named current inside my phones list, I'm going to go through and do system.out.print current.get service provider. So I'm going to grab the service provider. I'm going to just print that to the screen. And then I'm going to say, hey, current, set your camera type to the favorite word. Why? Well, I don't know. It's a great way. I'm going to set the cameras to all be my favorite word, supercalifragilisticexpialidocious. That's a great camera type, right? I thought so too. So logic into Morgan's law. So first, we have the exclamation point as the not operator. This inverts every or any logical value, operator, or relational operator. So it's going to take whatever it is and turn it to the opposite. So if it's and, it becomes or. If it's or, it becomes and. If it's greater than, it becomes less than or equal to. The and operator is the ampersand, ampersand. Both sides of the equation must be true. So and all, both must be true. The pipe key, aka that vertical line right there, is the or operator. Either side or both of that equation can be true. And so we have then De Morgan's law, the exclamation point acts like multiplying by -1 and is distributed across the entire thing. It's how we simplify complex logical equations. And so in the quick little example right here, we have not and then parens, x and not y would come reduced down to not x or y. And so that's the same thing. They are logically, these things are logically equivalent, and that's how we can use that and make that happen. Short circuit evaluation is the next topic we're looking at with this. So short circuit evaluation continues on with the idea of Boolean logic. As soon as we see a false value in an AND operation, we stop looking. So if we have a false as our first value when we're doing defensive programming, like so if variable name equals null and blah, 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 that AND is where we're going to check the things that check to make sure we can go inside that. That false value on that equals null means, oh, if it's not equal to null, then I can go through and I can continue looking with that. So we've got that right there. However, the short circuit evaluation on an OR, as soon as I get a true value, I stop looking and just immediately go in. And so as soon as I have a true value with that, so if value equals whatever, as soon as I have something that's true, I don't have to continue on. And so as soon as a true value is included, I immediately drop into my equation and go from there. Design is a big deal. We have to write good code, and that's one of the things we've been working with as we talk about the AP Computer Science A class. You want to make sure you plan your code before you write it. Now we're taking multiple choice exams questions right now, so we're not doing a lot of code writing, but as you're looking and reading those questions themselves and figuring out which is the best solution, this is where your brain comes into play, and that's how we can figure out some of those pieces. You want to examine the problem itself and identify the needs. One of the great ways to do that is take a look at the nouns. Nouns become the objects and the data members that we're working with for the actual problem itself. The verbs become the methods because that's what we're doing, the actions that are performed. And finally, the adjectives or adverbs are how I modify those existing things, usually as parameters to send that information to it. That's a great way to help look at and actually identify that so you can use that deeper knowledge back from elementary school and use it to apply to computer science and get greater understanding. We also want to talk about design. We're using encapsulation. We want to put this in a small chunk so it's easy to understand and easy to work. So we don't have to do giant, huge things. We make small little things like, again, a method does one thing well, a class holds one kind of thing. We use the kind of pieces that make the most sense. We want to also make sure that our data and our methods are private unless they're explicitly needed to be externally used. So if you have a data member, those are always private. That's just the standard rule that always applies for data members or local or class variables or instance variables or properties or fields or whatever your textbook and your teacher call them. We have constructors should initialize all of our data members. Great idea for that. If we have a data member, it needs to be initialized in the constructor. Our methods should be private unless they're told to be public. Oh, I need to call this a method externally. That means it's a public method. I never need this method. I'll just make it private to start, and then I'll change it if I need to later on and make it public as necessary. Just a quick little idea, encapsulation, we try and make things as small and self-contained as possible, and we only share them when we need to. ArrayLists and arrays. These are two linear data structures we work with in Computer Science A. ArrayList is my favorite one. It's an import needed structure. We have to use import java.util.arraylist when we're writing code with that inside our actual projects. They are dynamically sized. They grow and they shrink as we need them to. We have the angle brackets type that go alongside the actual word. So anytime we're using the word ArrayList inside the code, we have the angle bracket type next to it because that tells us what's inside that actual structure. We have methods we positively have to know. The get method takes an int index as a parameter and returns the type of thing that's stored inside that. That's how we retrieve items from the list. The set method takes an index and a value as parameters and returns the value that was originally stored in the list at that time. The add method takes a value as a parameter, returns a Boolean. That Boolean is always true. You don't ever have to worry about it giving false back because it can't. The add method with two parameters, the index and value, adds this item at a certain spot in the list and returns nothing back to you. It simply just puts it in the list. The remove method that takes an index as a parameter returns the value that was stored at that, the type of thing that was stored at that spot. And finally, size tells you how big that thing is. That gives us an int back. Arrays are a bit different. Arrays are fixed size. They don't change in size. They have no methods. Yes. They also have a single public data member named .length is how we figure out how big it is. They use the subscript notation or square brackets based. As you can see right here, a variable named retrieved value is assigned what's at the array at that index. Or if I want to assign into that index, I use array name subindex and I assign it the inserted value. That's all we can really do with array. It just holds things. That's all it does, nothing else. A 2D array is special. A 2D array is an array of arrays. And so each row is an array of the type stored in that 2D array. You might have seen that reference to as a egg carton because you've got a row and column system that you can actually work with and use in that. A great way to talk about that. I have, again, lots of videos that go in more detail on this. We initialize that with type and then two sets of square brackets. Name is a new type, passing it the rows and then the columns with that. And so int 2D array grid is a new int array of 5 rows and 10 columns. And car 2D array parking lot is a new car 2D array, passing it 20 rows and 2 columns. We can access the row count via ArrayName.length. The column count can access via ArrayName sub0.length, and we can access an individual cell inside that 2D array via ArrayName subrow subcall, just like we did with the array access earlier to either assign to or retrieve from that 2D array. Continuing on with 2D arrays, we've got a couple examples right here. We also have, as in our examples right here, we have the logical idea that a 2D array is really an array of arrays. So as we see right here in the yellow, we have our 2D array sample array, and each row itself is an array of cells. And it's like, oh, so in spot 0, which is in sample array, I have my columns 0, 1, 2, 3. In cell 1, I have columns 0, 1, 2, 3. In cell 2, I have 0, 1, 2, 3. And in cell row 3, I have cells 1, 0, 1, 2, 3, which are each of those columns. So sub 0, 1 would be going over here to the 0 cell and then going to the 1 column. Sub 2, 2 would be going over to the row 2 and then sub 2 inside that to make sure we talk about that. So that's how we access that. We can also see this over here with our demo code right here. So I have int 2D array numbers, and we're using an initialization list for that. And so I have 1, 2, 3, 9, 8, 7, and string 2D array words is equal to APCS 2D arrays are guaranteed to be rectangular in shape, exclamation mark. And so we can always see they're always going to be rectangular structures when we're talking about 2D arrays with Java. So we have for int row is 0, row is less than numbers dot length, row plus plus. For int call is 0, call is less than numbers sub 0 dot length, and call plus plus, again, we're guaranteed to access a rectangular structure by using the sub 0 dot length. And then system.out.println numbers sub row sub call plus a space. And then in every row we do a blank line to go to the next thing. And then for string array word row in words, then for string word inside words row, I'm going to go and use a for each to process this as well. And then system.print word in a space. And then at the end of every row, I print a new blank line. So 2 different ways to process that same 2D array's worth of information. Great thing to keep in mind. Always remember how to process 2D arrays. 2D traversal. So we just saw a couple examples of that right there. The standard row major traversal is what we just showed of how to go top to down, left to right. It's a nested set of loops. So the outer loop is the row, the inner loop is the columns, and a for each can only do it in a standard row major order. A column major order is left to right and then top down, where the columns are the outer loop and then rows are the inner loop. And you can't use a for each to do that. Other traversals of 2D arrays are definitely going to be needed to know how to do. You might need to go backwards through the 2D array by row. You might need to go up and down in a booster photonic order through the 2D array. There's lots of different ways to make sure you can do that, but you want to make sure you practice going through that as well. But the standard 2D traversal is either a row major or column major order, but you do need to know how to traverse other ways by using the logic and making sure you go within bounds. Iterative sorting. We have a couple examples of algorithms you need to know right here. You have to know insertion sort and selection sort. I'm not displaying the code for this because, again, you should have covered this in class and you can do more detail on my insertion sort and selection sort videos that are available for this. On the insertion sort, you're going to have to start the outer loop at 1. The local variable is going to hold the current value. The index variable for the outer loop minus 1. For the inner loop is going to be a while loop, making sure the inner is greater than 0, and its comparison of the data that's at that inner index is less than the current value. And then we'll slide the values down as we go through that loop, and this updates the outer values index. It's the quote-unquote faster of the iterative sorts. The selection sort is just a set of nested for loops with a swap method. So it selects the smallest value in inner loop via index, and if those indices don't match it calls the swap method to swap those values inside that structure. Pretty simple. These are both really easy algorithms to identify and understand. The nested set of for loops for this and a swap method for selection, a outer for loop with an inner while loop for the insertion sort. Great way to identify that and track what's going to happen. Merge sort is the recursive sort you definitely need to know. If the current structure size is less than or equal to 2, we're going to sort the contents and return the sorted structure whoever called me. Otherwise, I'm going to call merge sort on each half of that supplied structure, and then I'll merge those results back from that merge sort. So I can break the problem down in smaller pieces. Again, this is just a quick review of the sort. Take a look at the videos that go into more detail on how to do the recursive sorting. You'll understand that a lot better. Searching. I have iterative searches. I want to start at one end and compare against each subsequent value. These are loop-based structures. I can also use a binary search. I'm going to use divide and conquer, aka recursion, to make that happen as well. Binary search, you want to make sure you're always using sorted data, otherwise it's not going to be useful at all. And you start in the middle and make decisions to go left or right based on the sorted value of that. And it's recursive, like I just said. Just keep that in mind as you go through it. Errors. There's different kinds of errors you can see when you're working with Java. Syntax error is the idea of a typo. You name something incorrectly. It's not matching what you're doing. You're calling the wrong kind of thing. This is the red underline of doom if you're working inside your IDE and it gives you color-coded error message. It won't let you compile if you have a syntax error. A logic error is a little bit different. A logic error, your code compiles just fine, but it's performing incorrectly. Say, for example, you have a method that should be returning 5, instead gives you negative 99. That's a problem. There's something wrong with your logic. Your code compiles and works, but it doesn't execute the way you're expecting it to. Then we have a runtime error. This is where your code and your logic or some input causes that application to crash. Your program's running along nice and happy, and then it crashes and burns and throws some exception. And the exceptions are the things we're going to be looking at here next. The first exception we'll be looking at is a null pointer exception. You tried to access internal data on an uninitialized object, so something didn't get initialized in the constructor, or maybe when you're writing your constructor, you accidentally put void in the header of that. No, don't do that. So make sure it initializes all your data members inside your constructor or anything that you're working with. Arithmetic exception, you're doing your math wrong. This meant you tried to divide by 0 on an int type. It won't work. So make sure that when you're working with the idea of math, you have the right kind of data types as you do so. A string index out of bounds exception, an index out of bounds exception, or an array index out of bounds exception meant you went to the wrong spot in the thing. So you went to either an index that doesn't exist, like it's aka less than 0, or you went to an index that is greater than length, or size because you went outside of the bounds. So you have to make sure you only stay within the bounds of that, either the structure or the variable as you work through that. The next one you might have to worry about is a concurrent modification exception. This meant you tried to use an array list. This meant you tried to modify some array list using a for each. You tried to call .add, .remove, or .set inside of for each. You can't do that. For eaches are only designed to retrieve values out of that and call mutator methods if necessary. But you can't add, remove, or replace values inside them. Inheritance. So many different things we can talk about this, but again, we're just doing a quick little version of this lecture so we can talk about the major concepts. It's using design to simplify your code. We have a hierarchical design where we have a top type at the up, and then we have subtypes that go underneath it. It uses the extends keyword as the keyword for that. Our child classes have access to all the public parent methods, and there is no access to private data. So I can't access private data, but I can access the public methods. This is why we have getters and setters, because I can access the private data member by using a getter or a setter to access or retrieve that value. We use super parens to call the parent class constructor, and that should be done as the first line of the child's constructor. We use super dot to access the public methods of the parent classes, so we can do those things inside that. Now, one of the things that's kind of special, parent classes have no idea whatsoever about child classes or the child class methods. You can't use anything in them from the parent class. Here's a quick example of some inheritance. So a public class parent class has two data members, a private string description, a private int count. The constructor of the parent class is public parent class matching the same name. This dot description is assigned parent, this dot count is assigned 10. We do have a public void do math method where this dot count is assigned the original value plus 100. Get description returns the description, get count returns count, set description changes the description variable, set count changes the count variable. Great stuff. Then we have our class child class extends parent class, and our constructor of that child class calls super as its first line, then it calls the set description method, which it doesn't have, but it goes to the parent class, uses that to set the description to be child, and then calls the set count method to set that variable to be -10. Its do method overrides the original version, and it says, hey, current, you're assigned the value of get count. I'm going to call super.doMath, so I can use the super dot to call a parent method. Then I'm going to say update is to be get count. I'm going to do the set count to reassign a value now to be current plus updated, so I can add that value back in and set that as the new value for the count variable. Recursion. I want to call something with myself. So a parameterized method that calls itself with a modified parameter is the big thing we have with this. Base case is when recursion stops. The recursive case is when we keep going. And the Stack Overflow is not just a website. It's what happens when we don't have a correct base case and it keeps going, and crashes. On the multiple choice part of the exam, we only have to trace this. That's all you'll have to do. So make sure you can trace through that. There's great things to do as you do that. Make sure you write calls to the stack. It's a great way to keep track of it. One of the ways you can do that is by using a spiral. So if your method call of 9 and it leaves 10 on the result, then I have a method call of 8, which leaves 9 on the stack. Then I have a method call of 7, leaves 8 on the stack, 6, 7, 5, 6, 4, 5, 3, 4, 2, 3, 1, 2, 0, 1, 1. And so I have that 1 that times back times 1, times 2, times 3, times 4, times 5, times 6, times 7, times 8, times 9, times 10. And so I have to calculate the factorial of that by using recursion with that as a description to make that happen. Great little quick demo, but keep that in mind. You can always draw little short descriptions to help you do that through the test. Static means it belongs to the class, not the instance. Static means you have no access to internal state. It doesn't know anything about the actual class itself. With static means you can only use other static methods. And if you're talking about variables, you can only use local variables that are inside that method itself or static variables that are designed to the class, like a constant. And there's no use whatsoever of this dot. I don't get to use any of this dot at all in a static method. An example right here, we have scaled random. It takes a public static int scaled random, takes an int scalar, and an int scaled is equal to int math.random times scalar, it returns scaled. Public static int scaled shift random, which is int scalar and shift, and then I have that value where I take the scalar and the shift, and I put that in there as a random number. And then my main method, because main is also a static method, I can call that, and I do it static examples dot scaled random, static examples dot scaled and shifted random, or because it's inside the same class, I can simply just call it statically, and Eclipse right here gives me the italicized thing, so I know it's static as well, and it's first and second, so it always only calls static methods inside static classes. So that's a great way we can go and review those concepts. A couple quick tricks before we end for the day. Use the Java language guide at the very front of the exam. Use that throughout the exam itself. Look at the questions you were given for some good code samples. If there's a good code sample in a question, use that for later on if you have a question or have a brain fart and you can't remember what you're doing. This is a great thing for classes, for loops, and just general code ideas. One of the things I recommend all my students always do is write a standard 2D for loop on the beginning of your test so you know how to do that. It gets your brain up and ready to go, and you have that 2D array reference. You can go, oh, I know how to do this. This is something I can do, and I have that ready to go, and I can use that as I go through the exam. Review this things, take a look at any of those videos, scrub back and forth through the stuff if you need to. Hey, I hope this is a helpful review for the exam. Cheers, do a great job. See you next time. Bye-bye.